Problem number 3 says, determine the force in cable AC and AB to hold 20 kilogram ball D in equilibrium. Assume that F is equal to 300 newtons and D is equal to 1 meter. Okay, so first thing, this is the 2D equilibrium problem. So we know that we need to first draw the free body diagram. Let's draw it. So this is my FAB. This is my FAC. Okay, but first, we don't know the angles, but we do know the horizontal and vertical distance. So we are able to use the Pythagorean theorem to find out what the hypotenuse is. So for FAB, I know that along my y direction would be 1.5 plus 1 would be 2.5. Okay, it could be 2.5, but I'm gonna double it. So I'm just calling it 5. And then in the x direction I have 2, but since I double my y, I have to double my x will be, so I call it 4. And then if I put this in the calculator, I get 5 squared plus 4 squared, square root of 41. Okay, or you can say that just follow the image 2.5 2. You get 2 squared plus 2.5 squared. You get square root of 10.25. I just do it that way because that way I don't have to deal with the decimals, but either way is right. Okay. And then my FAC is only 1 in the y and then 2 in the x, and then I get square root of 5. Okay. Then I have my force 300 newtons here, and then my weight. So my weight is equal to the mass multiplied by the gravity, which the mass is 20k multiplied by the gravity constant 9.81. I get weight is equal to 196.2 newtons. Okay, so next thing we'll have to do is apply my equation of equilibrium to find out the force in cable AB and AC. Okay, so summation of force in the x direction equal to 0. In the x direction, I have a negative 300. No, not negative 300, because this is my positive x and this is my positive y. So 300 minus FAB. FAB x component will be 4 over 5. I mean, my bad, 4 over square root of 41 minus FAC, 2 over square root of 5 equal to 0. And then if I move 300 onto the other side, and then simplify this down, 0.6247 FAB plus 0.8944 FAC equal 300. But look at it, we have 2 unknowns in one equation. What can we do about it? We cannot do anything about it. So what we have to do is that we have to take a look at the y direction and see if we can find any useful information. So summation of the force along the y direction is 0. I have my FAB 5 over square root of 41 plus FAC 1 over square root of 5 minus the weight 196.2 equal to 0. Simplify it down. Okay, and also 2 unknowns in 2 equations. I mean 2 unknowns in that one equation. What can we do? So what we can do at this point, that either equation right here, we can rearrange FAB and FAC in terms of the other, and then plug it back into the other equation to solve. What I mean by that is that, let's take example, use this one right here. So I can turn this equation right here in terms of FAC. So I can say FAC is equal to, so move this FAB over here. So I got 300 minus 0.6247 FAB divided by 0.8944. Okay. So I rearrange this equation in terms of FAC, and then I can plug this FAC back in here. So what I get is that 0.7809 FAB plus 0.4472. FAC is 300 minus 0.6247 FAB over 0.8944 equal to 196.2. And then if I simplify everything, because right now the only unknown here is FAB, right? So I can get my FAB is equal to 98.6 newtons. And then after I have my FAB, plug FAB back in here to find FAC. So I get my FAC with 267 newtons. Okay. Pretty simple, easy, and straightforward, right? Because I found out the forcing cable AC and AB that are able to hold 20 kilogram ball in equilibrium. Okay, so problem number 4 is the same kind of problem as in problem 3, but it's just asking for different parameters. So problem 4 says, assume the ball B has a mass of 20 kilograms and the force of 100 newtons applied horizontally to the right of A. Determine the largest dimension B so that the force FAC is 0 for equilibrium. So this time, it didn't give you what D is. Okay, so we need to find out what D is. First, we have to draw the free body diagram. So we know that the weight is equal to 20 multiplied by 9.81. That's 196.2 newtons. 100 newtons applied to the right. Yeah, my FAC. And then this is the angle. We didn't know what the angle is. Okay, so for this kind of problem, after we draw the free body diagram, we have to apply our equation of equilibrium. So solution for this in the x direction. So in the x direction, I have 100 minus FAC cosine of theta equal to 0. Rearrange the equations. So I have my FAC cosine of theta is equal to 100. Same thing, summation of force in the y direction. I have my FAB sine of theta minus 196.2 equal to 0. Rearrange the equation. I got my FAB sine theta is equal to 196.2. Okay, what we can do at this point, same thing that we did in the previous, oh, my bad. This shouldn't be FAB, this should be FAC, because we are trying to find the large dimension D so that so the AC is equal to equilibrium. So there's FAC, my bad. So what we can do at this point, well, same thing as we did in the previous example. We can rearrange the equation in terms of the other, because we have two unknowns in one equation. We don't know what FAC is. We don't know what cosine theta. I mean, we don't know what theta is. So what I would do right here is that I will rearrange this equation right here in terms of FAC. So FAC is equal to 100 cosine theta, and then I can plug this 100 cosine theta equal to in here. So I got my 100 cosine of theta sine of theta is equal to 196.2. Yeah, so distribute sine theta in. This is what I got. And then reduce the numbers. Okay, and then we know that sine theta over cosine theta is equal to tangent theta, right? For our trigonometry. So then tangent theta equal to 1.962. And then we can just take inverse of tangent to find out what theta is. Theta is equal to 63 degrees. Okay, so we found out what theta is. What can we do to find out d? Okay, so let's say 60 degree right here. Okay, what we can do at this point. So what we can do, so we can take tangent is equal to, yes, opposite over adjacent. Opposite is d, the adjacent is 2. Angle for tangent, 63, okay? And then we simply find out that d will be equal to, let me see. So I got my d is equal to 3.925 meter, okay? And that's it for problem 4. Problem 5 says a trolley that moves along a horizontal beam is acted upon by 2 forces as shown. Knowing that alpha is equal to 25 degrees, determine the trigonometry of the magnitude of the force P so that the resultant force exerted on the trolley is vertical. Okay, so this is a 2D vector problem, parallelogram law problem. So first thing we know that alpha is equal to 25, okay? And we know that we need to determine the magnitude of the force P so that the resultant force is vertical. So, and we know that the resultant force is always between two vector force, which is between 1600 and P. And it says it's directly vertical. So I'm pretty sure it's going to be right here. So then FR. And then by parallelogram law, I can bring this P over here. Okay, let's call this FP. Okay. And then from trigonometry, I know that this is 25 here, then this must be 25 as well, right? This is 25. And then we know that I know that this is 90-degree angle. So this part right here is simply just 90 minus 15 equals 75, right? Okay. So I got that this is equal to 75. And then my base angle beta. So beta will be equal to 180 because I know that a triangle has 180 degrees. Minus 75 minus 25. Get my beta is equal to 80. Okay. And then the problem is asking to find what's the FP, which is the force P. So I can just use my law of sine. So it's like 1600 over sine of what's opposite of it, 25 degrees, equal to FP over sine of 75. Okay, at this point, simply just solve for FP. Get my FP is equal to 3660 newtons. Okay, that's it for problem 5. It's very easy as 7-4, right? And yes, this will be type of multiple choice problem that he will give you guys on the exam. The level of difficulty is just stressed out, right? It's not going to be as hard as the homework because the homework is trying to train you, to practice you, to getting used to solving those kind of problems. But the exam is not going to be as hard as the homework. Okay. So problem 6, it says if FB is equal to 30 pounds and FC is equal to 45 pounds, determine the resultant moment about the ball at A. Okay. I know the summation of all the moments at A will be equal to 0. And then I say counterclockwise positive. So I get my MA. So I get my also negative MA. I have a force right here, FB, but it's at an angle. So this should be the FB I should take consideration about, so that 2.5 feet is perpendicular to FB. MA plus Y plus, because it's going counterclockwise, and I assume that counterclockwise is positive, plus FB. This is cosine of 25, which FB is equal to 30 pounds. And then the perpendicular distance is 2.5 feet, plus FC, same thing. I have to take this FC, not this one, because this is at an angle as well. So that if take this my FC cosine 30, so that my perpendicular distance is 2.5 feet plus 0.75 feet. FC cosine 30, 2.5 plus 0.75 equal to 0. FC, I know that is equal to 45. Okay, so solve for MA. So my MA will be equal to 196 pounds per feet. And I can say that's counterclockwise because my initial assumption is correct. Okay, problem 7. This is a 3D moment problems about a force moment about a point. Okay, so for this kind of problem, first thing we need to do is that determine their coordinates. So I have A, B, C, and D right here. For A, I know that's at the origin, so it's all 0. B is down here, so it's 4 in the X, 2 in the Y, and then 2 in the Z. C, that's 4 in the X, 2 in the Y, and 0 in the C. D, that's 4 in the X, and 0 in both Y and Z. Okay. Next thing what I have to do is that I know that I have to use this formula right here. MA is equal to R or class F. And this F will be FR because there's 2 force vector right here. And I know that my FR is equal to simply just add them together. So my FR is 7I plus 22J minus AK. Yeah. And then what's my R? That's the tricky problem right here. As I mentioned, when we going over the concepts, I said that moment of a force about a point, R will always be from where the force, where the problem is asking you to find a moment, which is at A, to where the force is acting, which is at B. So my R will be RAB. Okay, did I make it clear? So the moment of the force about a specific point the R is always from where the problem is asking you to find that point to where the force is acting. Okay, so this is extremely important. Otherwise, because this is the fundamental concept for this type of problem. Okay, so let's find my RAB. So my RAB is RAB simply just RB because A is about the origin. So RAB is 4, 3, and -2. Then I have my RAB, I have my FR. So right now I can set off my cross product. Okay, so the first row will always be R, my vector. So 4, 3, -2. Second row will always be my FR, which is 7, 22, -8. Okay, that's equal to, so what's my I? My I will be 3 multiplied by -8 minus -2 multiplied by 22. So because what we did is that we cross out the row where I is, and we cross out the column where I is, and we only consider those 2 parts. That's I. And then for J, we know that we always want to have a negative sign from the J. Okay, J, same thing, cross out the row where J is, cross out the column where J is, and then do 4 multiplied by negative A, and negative 2 multiplied by 7. And plus the K, okay, that's 4 multiplied by 22 plus 3 multiplied by 7. Then if you put this in the calculator, you're going to get MA is equal to 20I plus 18J plus 67K. And that's the MA in Cartesian vector form. How to find out its magnitude? We know that simply just take square root of them and then square root of them. Okay, pretty easy and simple and straightforward. So let's move on to problem A. Okay, problem A says the load at A creates a force of 60 pounds in wire AB. Express this force as a Cartesian vector acting on A and directed towards B as shown. Okay, so acting on A and directed towards B. So R will be RAB, right? Because that's what it says in the problem statement. And let's find out what A is and what B is. The coordinate for A is right here. 0 in the X, 0 in the Y, and negative 10 in the K. For B has an angle right here. So this is 5 here, right here. This is my Y, and this is my X. And they both acting along the positive axis, their positive axis. So B does 5 sine of 30, 5 cosine of 30. And doesn't have any along the Z. So my RAB, that's equal to RB minus RA. That's equal to 5 sine of 30 plus 5 cosine 30 and plus 10, because 0 minus negative 10, that's positive 10. And then my UAB vector. So magnitude of RAB, that's square root of 125. So UAB, that's our RAB vector divided by RAB magnitude. Over so 25. Put this in the calculator, and you're gonna get UAB will be equal to 0.2236I plus 0.3873J plus 0.8944K. Okay, next thing, we need to express the force in the Cartesian vector form. So force vector equal to the force magnitude, which is 60 pounds right here, multiplied by UAB. Just this, okay, and then distributes the 60 in, so I get my F vector will be equal to 13.4I plus 23.2J plus 53.7K. Don't forget the units. Okay. So that's all for problem A, and I'll see you guys in problem 9. So the problem 9 says determine, the spring BA and BC each have a stiffness of 500 millimeter and an unstretched length of 3 meters. Determine the horizontal force F applied to the core, which is attached to the small ring B. So that the displacement of the ring from the wall is D equal to 1.5. So first thing, what we know that unstretched length, I don't know, it's 3 meter. What's my stretched length? So my stretch length, which, I mean, by stretching and unstretching, I mean this this length at a diagonal, not directly vertical or horizontal. So my stretch length is actually going to be because this distance to this is right here is 3 meter. This D, after it's been stretched is 1.5. How do I know this is after it's been stretched? Because it says so that the displacement of the ring, displacement means that it's already been stretched. So L will be simply just a 3 square plus 1.5 square, because I'm just doing hypotenuse, right? I mean, I bet I'm just doing a Pythagorean theorem right now, right here. So get L equal to, let me see, be equal to square root of 11.25. Okay, and then next thing we'll have to do is that I can apply my equation of equilibrium. So since I want to find out what's my f, and that's directly along the x component, so I'm just going to do summation force in the x direction first. So I have, let's call this t, and this is as well as t. And those t are actually going to have the same value because all their parameters is going to be the same. So I'm going to say it's 2t. Okay. And then their x component, of course, that's going to be 1.5 over square root of 11.25. Okay, because this is square root of 11.25. I don't know what this is. Yeah, I do know that this is 3 meter. Yeah, this is 1.5. And then since I'm finding the x, I'm just going to do that adjacent hypotenuse, so 1.5 square root of 11.25. Okay, which I have it right here. And then minus f equals 0. And then I don't know my t is. My t, I know that that's going to be that because that's a spin force, so that's ks. K is equal to 500 newton per meter. What's my s? We know that s is equal to L minus L naught, right? So it'd be square root of 11.25 minus 3. Okay, then let me see what I have for this one. I got t is equal to 177.05. Continuation of this right here. So 2 multiplied by 177.05 multiplied by 1.5 over square root of 11.25 minus f equals 0. Very simple. Solve for f. I get my f is equal to 158 newtons. Okay, guys. So that's all for this exam review session. I went over 9 problems and I focusing a lot on the free response problem because I really want you guys to get right. So I have included 2 free response problems for each free response problem. Okay, and then yeah, that's it. So this is our exam 1 review session, and I hope you guys can watch the video before the exam. Please do. If you have any questions or concerns, please don't hesitate to email me. Okay. All right. Thank you guys so much, and good luck to your exam.